Okay. Let's get started. Hey guys, welcome back to another one of the A-Level free tuition lessons. Today we're going to be doing all of the cosine and sine rule and area of a triangle questions that can come up. So I've got another video on this but for the GCSE side, but to be honest, the A-Level and GCSE content are very, very similar for this topic. However, it's going to be obviously on the higher end, right? So it's going to be a bit trickier. So without further ado, let's get into it. So we have a triangle ABC. So what I like to do in all of these questions is to draw out exactly what we're talking about. So we can just label them from left to right, A, B, C. Side AB is length 15 centimeters, AC is 12 centimeters, and BAC, so that's the angle between them, is 60 degrees. And for A, it just says, find the length BC. It's looking for this one here. So all you need to do here is, if we label this X for example, is we can use the cosine rule because it's pretty much the same. However, there are some differences. So I would say it's probably on the higher end of the GCSE spectrum. But there are some kind of quadratic equations and stuff that come up a bit later. But it is fairly similar. Okay. And as you can see, we have two sides and the angle between them. So to work out the opposite side to the angle, we're going to be using the cosine rule. As a reminder, yeah, sure. So far all I've done is I've literally just started. This is the first question. Okay. So we've literally just drawn out the diagram and labelled the sides. Okay. Minus 2bc cos A. Now if the letters kind of confuse you, just remember that the side A is always opposite the angle they give you, and sides B and C are the ones that make up the angle. Okay, so you have these three pieces and the opposite side. So if we just sub in what we have here, that means x squared is equal to b squared. It doesn't really matter which way around you do it, so if we just say 18 squared plus 12 squared minus 2, 15, 12, then cos 60. So again, shouldn't be too bad. Just do the whole thing on a calculator. So if I just get my calculator up. So we have 15 squared plus 12 squared minus 2. B is again 15. Again, it doesn't matter which way around you actually put them because you're just adding them or timesing them. So this calculator, you can get it from the Casio website. You can get a free trial for a few months, but I actually pay for mine because I use it in so many different things. So yeah, equals, so it doesn't actually equal that, it equals the square root of that, because don't forget it's a squared, not just a. That's 3 root 21, but it doesn't tell if they want it to any kind of significant figures, so we're just going to write 13.7. And that's it. And that's 3 marks, so hopefully not too bad. If you have any questions, please stop me and let me know, and I'll continue. Bear in mind there is a delay on the stream though. So circles and absolutely. That will come up shortly. Let me actually see exactly when I plan to do that. So the equation of a circle we did 2 weeks ago. And we did the transforming graphs 4 weeks ago. So you can go back and have a look at those. So 2 weeks ago there was the circle lesson, which is the equation of a circle and all that stuff. And for part B, it just says calculate the area. So if you remember, the area of a non-right angle triangle is just half AB sine C, where again A and B are just the two sides that make up C. So if you have like an angle like this, that would be angle C, and A and B are the ones that make up that angle. So we only have one angle, it's 60, so let's just choose these two sides. and that will give me the area. Yeah. So half, so I'm just going to call it 0.5 times 15 times 12, and then sine 60. 45 root 3, which is 77.9 centimeters squared. And again, don't forget the units because they are very particular about the units. So again, not too bad to begin with, but it's going to get trickier and trickier as we go along, so please let me know if it gets too tricky. Okay. So again, this question, again, it's fairly similar, but it's slightly more tricky. We once again have a triangle ABC, so let's just draw this out. AB has length 8 centimeters, BC has 7 centimeters, AC is 6 centimeters. And we need to find the size of the angle ABC, so ABC would be this angle here. Let's call it X degrees. So, for this question, once again, we use the cosine rule because we only have 3 sides and we want an angle, okay? So, we have however, we don't actually want the side, we want the angle. Okay, so if we label our sides up, this is going to be A, this is going to be capital A, and then B and C can be the 2 others. It doesn't actually matter which way round it is. Okay, so if I want to rearrange this equation for cos A, I would move it over to the other side. So I have 2bc cos A plus A squared equals B squared plus C squared. Subtract the A squared to move that over to the other side, and we get 2bc cos A equals B squared plus C squared minus A squared. And it does matter what you call A squared, but the other 2, it doesn't actually matter. And then lastly, divide by 2bc, and we get cos A equals B squared plus C squared minus A squared over 2bc. Nice. Now you can actually just go straight for the angle by inverse cosing everything and putting that all in a bracket. So B squared plus C squared minus A squared. So again, B squared plus C squared, that's 8 squared plus 7 squared. A squared is 6 squared in this case, so minus 6 squared over 2bc, so 2, 8, and 7. Now give you your answer. So if we use this, inverse cos, big bracket, 8 squared plus 7 squared minus 6 squared over 2, 8, and 7. Not too bad, hopefully. Again, let me know if you are stuck or if that doesn't make any sense. Now we just write and that's the 3. And lastly, all you need to do is find the area of the triangle. So again, all you need for the area of a triangle, a half AB sine C. So all you need is 2 sides and the angle between them, which we now have because we worked out the angle between 8 and 7. So the area is a half. A and B are the 2 sides that make up the angle, so 8 and 7. And sine 46.6. 5. And yeah, we get 20.3 centimeters squared. So again, hopefully this is just a recap of what you've done in GCSE. Okay, so hopefully that seems kind of familiar. Maybe some of the harder questions in GCSE. But are there any questions about that at all? Because it's going to get a bit more tricky now. Perfect, good to hear. So again, hopefully that's just a bit of a recap. So here is where something gets a bit more interesting, okay? So they give us a bunch of letters and numbers. If you notice, they don't tend to give you the actual triangle. So in triangle DEF, so let's just draw out a relatively big triangle and just call it DEF. Again, I don't actually know what it looks like, but it's a good model. ED is 5 centimeters, so let's do that. EF is 6 centimeters. Given that sine of angle DEF, so that would be this one, is 2/3. So let's call that angle X. So sine X is apparently 2/3. They also tell us that DEF is acute. So in other words, it's less than 90 degrees. It now says find the exact value of cos. Okay? So here's where things can get a bit more tricky or a bit interesting. If we come up with a triangle for sine x, right? We're going to make a right angle triangle out of what this angle is here. Now, if you remember from your SOHCAHTOA, sine theta is equal to opposite over hypotenuse. So in this triangle here that I'm creating, and again, whenever they ask you to find the exact value of cos and they give you sine or tan, or vice versa, you're going to create a right angle triangle with this, okay? Opposite over hypotenuse, but we know that our opposite over hypotenuse is 2/3. So opposite is 2, hypotenuse is 3. Okay? And if you remember that cos theta is equal to adjacent over hypotenuse, which will be this side here. So I already know that the hypotenuse is 3. I just need to work out the adjacent. So if I have a right angle triangle, I know two sides, I'm going to work out the third. I'm going to be using Pythagoras. And if I have the hypotenuse and I want to work out one of the other sides, all that means is I do the hypotenuse squared, subtract the other side squared. Now that's pretty tricky, but this comes up in mechanics, and it comes up a lot in your paper 1 and paper 2. Okay? So it comes up in AS and A2 content. So if you're not sure, please let me know. It's a bit tricky. Okay, really good question. So I'm just going to write this out and I'll get to it. So the question is, how comes we can use this when it's not a right angled triangle? Well, what they've given me is that sine of this angle in this not right angled triangle, right? So this triangle here isn't DEF. It's not this triangle. But if they tell me that sine of an angle is 2/3, I can create a new right angled triangle from that information. Okay? So can you see that? Okay? Because sine of an angle is always equal to opposite over hypotenuse. So I draw the second triangle because now I know what A is, it's root 5. I can work out what cos is. Absolutely, sure. So, let's start from the beginning, okay? They tell me about this triangle here, okay? This triangle is not actually needed for part A. Okay? It's not needed. So if you want, we can move this slightly further up. It's not needed for part A. The only information they give me is that sine x is 2/3. Okay. Now, if I just told you that sine x of an angle is 2/3, okay, so if we ignore that, and I just said sine x equals 2/3, what's cos x? Then would this working out make sense? So ignore the above triangle. If I just gave you this information, would it make sense that we can do this? Because what you'll find with A-level questions is that they're quite long. They give you like A, B, C, and D, and they're not always fully linked. Okay? So if I give you that sine x is equal to some fraction, I can always say, because that's what the answer is, that's what the question says, find cos. So what I did is I just called DEF x. So all they're asking me to do is find cos x. That's all that the question's asking you to do. So again, because of SOHCAHTOA, because that's what they've given us, they gave me sine x, and they want me to find out what cos x is. These are all really good questions, by the way. It's good you're asking this, because this is a brand new skill for A-level. It can be a bit tricky. So in general, if anyone says sine x equals this, what is cos x? You can always write it as a right angled triangle, because sine x is always equal to opposite over hypotenuse of a right angled triangle. Does that make sense? Ah, perfect. Perfect. It's a really confusing new skill, right? But this is what I mean by there's some new stuff in the cosine rule and sine rule when it comes to this. It is quite tricky. So that means in this case, cos x, which as we said over here is adjacent over hypotenuse, is just going to be root 5 over 3. And that's it. That all okay? So I think quite a few people just joined. If you're unsure of what we just did, let me know. And now is probably where we have to actually deal with the other triangle. So to be honest, this information isn't needed for the first part. So what we can do is I can take this and just drag it down to where I need it. And now from part B, we're actually using the information that we need. Okay. Now if sine x equals 2/3, then I can immediately work out what the answer is, right? I've seen your comment, just give me 2 seconds, I'm writing something. So basically use the sine rule, use sine to label the sides of the triangle, and then from there use Pythagoras to find cos. Then use the, yeah. So in parts B and C, we're actually going to be using the sine and cosine rule. But you don't need it for the first part, which is annoying. But yeah, well done. And we're going to be working the side DF out. Actually, let's not use X for this question. Really well done. No problem. Yeah, it's not too bad once you understand it, right? But it's the understanding, like the leap. It's quite difficult. But once you get it, it's not too bad. And now you know it, you're going to be able to do it really easily in future. But yeah, I think it's a bit of a tricky jump to make. So that angle is actually 41.81 even, if I can learn how to read. And perfect, okay. So part B literally just says find the length DF. So I've drawn the triangle out, I'm just looking for the length df. Okay. Honestly, I wouldn't mind, but there's not really much point because I don't think there's many other people here. I think it's just you. So I don't think it really means anything. Yeah, just working out df. So we have two sides and the angle between them. We want to work out the third side. So that means we're going to be using, again, the cosine rule. Again, classic. So in this case, my a squared is y squared, and b squared doesn't matter which way around we do it. 5 squared plus 6 squared minus 2, 5, 6 cos 41.81. And then all we need to do is square root it and get our value. Nice and easy. So 5 squared plus 6 squared minus 2, 5, 6 cos 41. Then square root the answer. 4.03, let's call it, centimeters. 3 significant figures. So again, that was another 4 marks. 4 marks just for that. It's not too bad. Most of your papers are probably out of 80 marks, depending on what paper you're doing. So I don't personally find it that tricky. And then lastly, part C, we're going to be using, find the angle EFD. Okay, cool. So EFD, that's going to be this angle over here. Let's call that Z. Okay. So what we can do is actually replace these letters now. So Y we've worked out is 4.03. We've worked out X to be a fairly long number, but 41.81. Okay. So if we want to work out a an angle and we have its opposite side and another angle side pair. So can you see that this angle is opposite this side and we have this side which is opposite the angle we want? We can use the sine rule. You can also use the cosine rule again, but that's quite long. Okay, so I'm just going to use the sine rule. And the sine rule just simply says, so again, I've seen your message, just give me 2 seconds to write out the sine rule and I'll read it. With a A-level math, I say I do really bad with the pure section, can be good. So. Yeah, so how about after the lesson, I'll go through all of that stuff. Is that okay? I'll definitely go through all of that. So, yeah, cool, perfect. So what we're going to do here, or I'll just talk about it after this question, whichever one you prefer. So all we have here is, this is the angle we want. We have its opposite side. We have another angle and another opposite side. So sine of the angle I want, which again I've just called Z. The opposite side is 5 centimeters. Equals sine of the other angle, which was, well actually we already know what it is, it's 2/3. So we don't have to write this out, but I'm going to write it out anyway. So instead of sine 41.81, I could have just put 2/3 because that's what it told me it was, over 4.03. And now this is a simple rearranging. So if I just times both sides by 5, I get that sine Z equals 5 sine 41.81 over 4.03. So if I go back up here, Z is just going to be the inverse sine of 5 sine 41.81 over 4.03. And we're done. A bit long, but not too bad. Inverse sine, bracket 5 sine 41.81, close bracket, down. $55.8 degrees to 3 significant figures. Okay, so question we just got asked, which is really good, really important, is essentially if you do all of us, virtually all exam boards, you have 3 papers. You have paper 1, or again, if they're called units, it doesn't matter, right? But you have 3 papers. You have paper 2, and then you have something called your applied paper, right? So again, if they're called something different in your exam board, it's still the same thing, right? You have 1 paper, 2 paper, and the applied section, which is the stats and mechanics, right? So, the question was, if I do really bad with one of the pure sections, can I make up with it with stats and mechanics? So, because there's 3 papers, in total, they're all going to make 33% of your grade. Right? Whoops. So they all give you 1/3 of the grade. So if you think about it that way, let's say you get 0% on paper 1, and then 100% on the next 2 papers, you still get 66%. It'll actually be 67% because of how that works. And what that will be is usually it's equivalent to a grade A or B. So you can make up for it, but it's best to kind of aim for like an average. I haven't really seen, most of the time, people actually do worse in applied than they do in pure. Most of the time. So, but you can technically make up for it, right? But that's the way I would work it out. I'd work out what percentage I got from this. So let's say I got 20% in total from here. Another 20%, that's 40%. I'd have to gain 30% here to get 70%, you know? So, the next question basically said, how many papers is there? So it's 3 papers. How many marks? All of them are worth the same, and it's usually 80 marks. But they're all worth the same amount. Okay? And lastly, what's the grade boundaries? Grade boundaries for maths change all the time. All the time. Every year it changes by quite a bit. Sometimes it's been as low as 50% for an A. Sometimes it's been as high as 80% for an A. So it varies so much. You can look up last year's grade boundaries if you want. Yeah, so with applied, it's all of mechanics and stats. So every single bit of mechanics and stats only appears in the applied paper. For paper 1, roughly, it breaks down to the stuff you did in AS, and this stuff is the stuff you did in A2. So generally speaking, it's a lot of the integration, differentiation, there's a lot of proofs. Whereas in AS, you have things like the cast diagram. You have algebraic division. Yes, that's correct. Paper 1 and 2 is only pure. Paper 3, or the third paper, is only stats and mechanics. Okay? Hopefully that answers your question. And that should be okay for that. But yeah, in general, paper 1 paper 1 and 2 are pure, so you might hear them called pure 1 and pure 2. Doesn't matter. 2 of the papers are pure only. Third paper is stats and mechanics only. But yeah, good question. To be honest, paper 1 tends to be the easier one. You get 1 grade. You get an overall grade. They'll tell you what you got in each paper, like a percentage, or as marks. So they might say you got 60% in paper 1, 70 in paper 2, 65 in paper 3. But you get 1 grade, which is your maths grade. Okay? Hopefully that's all okay. Excuse me, sorry. I'll drink some water and then we go on to the next question. So, again, it depends on the grade boundaries, but 86% is very good. So it'd be an A or an A star in most years. Okay? In fact, I'm pretty sure in almost every year that's been an A star. So, again, just look up last year's grade boundaries is the best way to do it. I mean, to be honest, the best way to do it is just aim for 100% in every paper. Because the thing is, if everyone does really badly in the country, the grade boundaries go down. If everyone does really well, the grade boundaries go up. So it depends on what happens in your year. Cool. Anyways, let's do the next question. So triangle PQR, so let's draw and call it P Q R. PQ length 9, PR length 10, and the overall area is 30 centimeters cubed, squared even. Okay. Yeah, so what it will do is they'll average it. So the way it would work is they take the mean, right? So let's say you get 30% in one paper and then 80 and 80 in the next two. They'll add them all up and then divide them by 3. So that gives you 190 divided by 3, you would get 63%. So all they do is they take the average, they take the mean. Okay. Part A, find the length of side QR. So the thing is, we can't actually go straight to working out what the length of the side is. So if you're ever unsure in an exam of what you need to do, just try and work some stuff out. Okay. So if they give me the area, let's think about what the area is. Well, the area is half AB sine C. So if they give me the area, I can work out the angle, which would be this angle here. Okay, so the area is 30, and that equals a half. AB is 9 and 10. Sine Y. So that would be 30 equals 45 sine Y. Divide it over, you get 30 over 45 equals sine Y. Which means Y is just inverse sine 30 over 45. (41.81 degrees). Okay, now does that bring me closer to working out the length of side QR? Well, I have an angle now and 2 sides, which means I can use the cosine rule to work out the last side. So again, in an exam, also keep in mind, everything you work out in an exam will give you marks. Okay? So even if you weren't sure what to do with this after you've done it, you've actually already gotten 3 of the 5 marks available. Right? So even though you haven't got an answer, you've got most of the marks. So never leave a question blank. Okay? If there's one thing you take away from this lesson, just make sure you always fill in the answer, fill something in, okay? Because that will give you marks. So we have 9 squared. Whoops, messed that one up. It's 10 squared minus 2, 9, 10, and then cos 41.81. all you have to do now is square root it, and you get 6.84 centimeters. To 3SF. Okay. Part B just says find the angle of PQR. PQR would be this angle over here, which I'm going to call Z. A bunch of different ways you can work this out. But probably the easiest one is the sine rule. So sine Z over the opposite side, which is 10 centimeters, equals the other angle side pair we have, which is sine of the angle we just worked out, 41.81. Over the opposite side to that, which is side X, which we worked on in the previous part, is 6.84. So therefore, sine Z, if you times both sides by 10, you just get 10 sine 41.81. And again, please stop me if you have any questions at all. It's the best way to learn. And then you get Z equals something. So Z is just going to be the inverse sine of that. Whoop, there we are. Well, inverse sine 10 sine 41.81 over 6.84. 77.1 degrees. And that'll be our answer. Okay, how was that? I don't think it was too bad. Again, just try and work out as much as you can. Generally speaking, you get marks for it. I have 2 more questions. And again, the last one is actually really difficult. Well, I say really difficult. It's advanced. So be sure to stick around to that. I can skip ahead to the more advanced one. Or we can just go through the next one as well. In fact, so let's have a look. Okay. This question is also quite interesting because it combines what we did last week, which was the cast diagram. But this is the extreme one, okay? So let's have a look at this one. So, let's draw our triangle. And you're probably going to notice something. Okay, I don't know what happened there. No idea what happened there. So A, B, C. AB is x plus 3. AC is x. And angle between them is 60 degrees. Work out the value of x. Okay, so again, I said this is pretty tricky. It's not that bad. But the problem I find with students sometimes is they look at something like this and they draw something like this and they panic and they shut down. Okay? Now think about it. Just use the cosine rule. Well done. That's exactly what you do. Oh, I actually forgot one of the other sides. All you need to do is use the cosine rule. Easy, right? So the cosine rule says that the opposite side squared, so let's do that. X plus 2 squared will equal the other side, so in this case x plus 3 plus a squared plus x squared minus 2 x plus 3 x cos 60. And then all you need to do is find out what the value of x is. So as you may know, cos 60 is 1/2. So that means that this 2 times 1/2 actually goes away. Because you have 2 times 1/2, which is 1. So this has actually become a lot easier. We have x plus 2 squared equals x plus 3 squared plus x squared minus x times x plus 3. So all we need to do now is it's a quadratic equation. So we just need to expand, simplify, and then use the quadratic formula or whatever else we want to do to work it out. So let's expand this. So that'll become x squared plus 4x plus 4 equals x squared plus 6x plus 9. If you're unsure of how I got to any of this, please let me know. So I'm going to leave it there for a few seconds. Make sure you can expand that in your head. Make sure that's okay. Or if you want me to go over it in more detail, let me know. Perfect. So these two x squareds cancel out. And now we're going to simplify both sides. We have x squared plus 4x plus 4 equals x squared. 6x minus 3x gives me 3x plus 9. So now, if I can actually get rid of both of these x squareds, because I can just minus x squared from both sides. So that gives me 4x plus 4 equals 3x plus 9. 3x is smaller than 4x, so I'm going to subtract 3x from both sides. We get x plus 4 equals 9 minus 4, so we get x equals 5. So that was one of the... I've mentioned this in quite a few of my videos, but 10% of your marks have to be unseen questions, okay? Which is where they give you something you've done before, like the cosine rule, but they give it in a situation you've never seen before. This was one of those unseen questions. And most students didn't even attempt it, and the ones that did got it wrong. So now I've gone through it, you might see how easy it is, but in an exam, it's very easy to panic when you see something you don't recognize. Yeah? Which hopefully makes sense. So again, in an exam, if you come across something you haven't seen before, which is guaranteed, don't panic, just try and use what you know. Because they have to give you something you're able to do. Okay? So we have some time. If you want, we can go through this question, which is they're all squared. Squared, squared, and squared, right? So in the diagram, all the lengths aren't squared, but in the cosine rule, we need to square all of them, right? So the cosine rule is a squared. So all of them are squared. It might just be my handwriting is a bit bad. Why does it have to be? Oh, good question. Okay. So, in the cosine rule, this side has to be opposite that angle. Okay? So these two things have to be opposite. If I have a look at my diagram, the angle 60 degrees is opposite x plus 2 squared. Because x plus 2 is the side BC. And the angle is BAC. So the only restriction on the cosine rule is that the A and the capital A have to be opposite each other for it to work. So in this case, x plus 2 has to be squared equals to the rest of it. Does that answer your question? Does that make sense? Well done, Alchemist. That's exactly right. Okay, so the last question that we'll go through. Again, this is one of those unseen ones because they combine two topics. Okay, so let's draw it out. Again, we have triangle ABC. So this question and the question we just did are some of the hardest questions you'll find with the cosine and sine rule. So if you're okay with it, brilliant. If not, that's again fine. just go over it one more time. 10 centimeters. BAC is 30 degrees. And it says find two possible sizes of the angles ABC. ABC here. Giving your answers to two decimal places. So I think this is quite important. But if I asked you sine x equals a half, what does x equal? I'm going to assume that most of you would go to your calculator and do inverse sine of a half, right? And you'll say that it equals 30 degrees. And you'll probably say that that's the only value. There's actually an infinite number of values. So if we look at the sine graph, right? It's probably the best I've ever drawn it, actually. It goes on forever, right? Now, if that's plus 1, a half is here. Look how many times the graph touches a half. It will touch it an infinite number of times. So this is a recap for those of you that missed my last lesson on the cast diagram. But essentially, for any value of sine, cos, or tan, there are an infinite number of answers. Okay? So when they're saying find two possible sides of the angle, well, the first things first, this is the sine rule, right? Because we have a side and its opposite angle, and we want another side and its opposite angle. Wait, I think I've labelled this BAC. That's fine. Yeah. Okay, slightly annoying. But we're going to be using the cosine rule. Sorry, the sine rule. Because we have a side and its opposite angle and another side, and we want to find its opposite angle. That will give us what the value for z is, okay? Now for y, so Alchemist, that's 100% correct. But there are other values of x as well, right? Because you have 180 minus x, but you can also do 360 minus x. However, we have a restriction on this. Okay, so we have this value, and I'm going to work out what y is, yeah? So you are 100% correct though, well done. Now, when I get this value of y, 40.5 degrees, let's call it. Actually, let's do it to two decimal places. The way I'm going to work out z, right, because that's what they're asking me for, right? They're actually asking me for z, this angle here. The way I'm going to work it out is I'm going to do 180, because all of the angles in the triangle add up to 180, minus 30 minus what y is. Okay? But they're asking me for all of the possible values of z because y has multiple different values. Okay? So what are the restrictions we have on angles in a triangle? Well, they can't be negative, right? They have to be greater than 0, right? I think that's a fair statement to say. Is there an upper limit? Well, they have to be less than 180 degrees. Because if one angle is 180 degrees, it means the other two angles are 0, which means we have a flat line. It's not a triangle. So let's look for other values of y that are within this range. So I believe, Alchemist, you use the basically the graph, but you use kind of 180 minus the value will give you the other value. It's 100% fine. I use the cast diagram because it gives me some other values as well. Although in this case, it will only give me that one value. So we found out that it's 40.54. The other place where, so the way the cast diagram works is you draw out your angle. And then you think of where else is it positive, because again, sine's positive. It's here. If you're unsure about this, I would recommend going to the previous video, which is where we did the cast diagram. I explain it in a lot more detail. But as Alchemist said, it'd be 180 minus the answer. But the idea is you can keep going around this diagram infinitely, right? Unless we have boundaries, okay? So if anyone ever asks you, if sine x is a half, what's x? You should say, what's the boundaries? Because there's an infinite number of answers, which of course isn't particularly useful. And so the other value would be, I did use a calculator, just being completely honest, because I don't really want to do mental maths to that extent yet. 139.46. So the values of z, there are two values. Either z equals 180 minus 30 minus 40.54, or z equals 180 minus 30 minus 139.46. Okay? And those would be our two values. There are no other values, because if we go any higher, we'll actually get a negative answer for z, right? Because if we go around again, it's going to be too big. So 180 minus 30 minus 40.54. We get a value of 109.46. That looks about right. Cool. And if we just change the last digit, it's 139.6. Again, I'm being a bit lazy. 10.54. That's it. So those last two questions we did, they were kind of unseen, supposed to kind of trip you up kind of questions. And again, if you notice, it combines topics, right? So this one, it combines cosine rule with solving quadratics. And this one combines sine rule and cast diagram, or solving trig equations. So what you can expect in your exam is that they'll try and combine two topics that they've never combined before. So you can kind of maybe predict roughly what they're going to do. Okay, but I'd recommend just doing as many questions as possible. I hope that helps. Do any of you have any questions? Alchemist, I think you've been here before, but welcome back if not, or welcome for the first time, but I feel like I recognise your name. But yeah, let me know if you want me to go over anything or double check anything. And again, I'm very proud of you guys actually messaging, using the chat function if you don't understand. It's the most important thing you can do. Again, treat this like tuition. Any questions at all? Oh wow, perfect. Oh, it is the first. Okay, fair enough. First time. I thought I recognised your name, but okay. Welcome for the first time then. In year 13, seeing further maths, cool. By any chance, do you do physics as well? Sat A-level maths already? Are you going to redo it to try and get a better grade? Or is this just for fun? Perfect. If there are no other questions, I think that went pretty well. Pretty happy with an A star. I mean, you can't really do much better than that. Really well done. Do physics as well, nice. I actually have a master's degree in physics, so I did maths and further maths and physics at A-level as well. Generally, people who do maths and further maths, generally speaking, do physics as well. But yeah, nice one. But really well done on an A star in maths. It's really good. Best combo, exactly. Yeah, standard. I assume you've applied for maybe physics or maybe computer science? No, you don't. you don't need to do further maths for engineering. You don't actually need further maths for physics, but it will help you in university for physics. But you don't need further maths to do engineering. No. My man. Absolutely. It's a good degree. Good fun. Well, yeah, congratulations on your A-star in maths though. Really well done. And definitely well done on doing physics. So I actually want to do physics lessons as well. I'm just trying to find the time to do it. Because at the moment, obviously, I work as well. You know, I'm not exactly making big bucks on YouTube or any money at all. But I do want to do physics videos as well. Quite desperately. Because that's definitely where my passion is. So, again, I would like to do further maths. At the moment, because I'm working, it's tricky to find the time. Because I have I also tutor as well. So I have tuition classes most days. And I work in a school. So I'm trying to find time because, again, further maths and physics content is that's definitely where I want to do stuff. So at the moment, I'm just trying to go through AS and A2 pure, AS and A2 regular maths, then AS and A2 further maths. So honestly, probably it'd be after you finish your course, unless I manage to stop working before then. If my tutoring picks up a bit more, then I'll be able to do more kind of live lessons for further maths as well. So fingers crossed. Yeah. So he's normally run until 7, but I think we're all okay with this. It's been great talking to you guys. But if there are no other questions, have a really good evening. Have a good weekend. Stop doing maths, do physics. I appreciate that, Alchemist. Thank you. Stop doing maths. I don't know. A lot of people have requested maths. But I do understand needing physics. Because it's very tricky. I'm going to try and find some time. Okay? I'll try and find some time. Maybe in the weekends. Although I don't know if people really want to watch physics videos on the weekends. But yeah. Also, yeah, I appreciate that, Alchemist. Thank you very much. But yeah, I'll let you guys get back to your evening. Enjoy your weekends as well. And I'll see you next week at the same time.